Okay, so today we're going to talk about logarithms, and so this video is really more just of an introduction about what a logarithm is and how we deal with them. And the main thing, before I go into more of a detailed definition of a logarithm, is basically it's an exponential function. It's just a different way of writing an exponential function. So that's the key thing that you want to keep in mind. Where you've dealt with exponents before, probably for a lot of you, logarithms are new, or it's a new word, it's a new concept, but at this very base is the same thing as an exponent. It's just a different way of writing it. And so logarithms are defined by this. So let me just write the whole thing and then I'll talk more about it. And so we would read this as log base b of y equals x, if and only if b to the power of x equals y. Okay, of course that's a lot of variables, kind of hard to keep in mind, keep everything straight. The main thing that you should be aware of right now, first of all, is that a logarithm always has a base. And so in this case the base is b, whereas an exponential function always has a base as well, and so whatever has the exponent is the base. And so what we're going to be doing to start with is we're going to be taking equations that are written as a logarithm equation and rewrite it as an exponential equation and vice versa. And the main thing to keep in mind is that no matter which way you write it, it's the same. The base is the same. Okay? So for example, let's start with log base 2 of 16 equals 4. Okay? And so this is log form, and then we're going to rewrite this in exponent form. Okay? So the base of this problem is what? It's 2. Okay? And so when we write it in exponent form, the base is still going to be 2. And so it becomes 2 to the power of 4 equals 16. And so when you write it in exponent form, of course, that makes sense to us because we deal with this some more. It just seems more intuitive. 2 to the power of 4 equals 16. Okay? This is going to seem a little more foreign just because you haven't seen it before. So try this one on your own. Log base 4 of 1 equals 0. Rewrite that into exponent form. 4 to the power of 0 equals 1. Last one, log base 1/4 of 4 equals -1. So when we rewrite that, the base is 1/4. So it's 1/4 to the power of -1 equals 4. Okay. Now let's work the other way. So if we start with something in exponent form, 5 squared equals 25. So when we rewrite that in log form, the base of this function is 5. So it's log base 5 of 25 equals 2. A to the power of 2/3 equals 4. Okay. Rewriting that in logarithmic form, the base is 8, so it's log base 8 of 4 equals 2/3. Okay, so in many ways it's just rewriting the pieces in a different manner when we go through this. So if we take a look at just a couple of examples, other problems that you might need to work through. Okay. And we're going to kind of take this with a trial and error approach to start with. There's other ways to do this. Okay. So let's start by trying to evaluate log base 4 of 64. Okay. So to do that, what I want to do is I'm just going to go ahead and rewrite this and set it equal to x. And so if we if we rewrite this as an exponential equation, the base is 4. So it's going to be 4 to the power of x equals 64. Well, 4 to what power equals 64? And that's 3. So x is equal to 3. So in other words, when we evaluate this, we would get 3. Okay. Let's try this one. Okay, so go ahead and figure this one out if you could. Log base 2 of 32. Alright, so if I set it equal to x, then it's 2 to the power of x equals 32. And so 2 to what power equals 32? Well, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32. So the answer here is 5. Okay. Alright, so let's take a look at a few others that are maybe a little harder to do. Oh, that should be 0.2. Okay. Okay, so if we rewrite it like we did before, it would be 5 to what power equals 0.2. Okay, so in this case, think about what is 0.2 as a fraction. It's 1/5. So 5 to the power of x equals 1/5. What exponent allows us to get from 5 to 1/5? And the key thing is that anytime you have a situation like this and you're going from a whole number to a fraction, or if you're going to a fraction to a whole number, be the same thing, then the exponent has to be negative. And so in this case, x has to be -1. 5 to the power of -1 is what equals 1/5. So the answer to our problem here is -1. Okay, let's try another one like that, or similar at least. Log base 1/5 of 125. Alright, so in this case we would have the base is 1/5, so 1/5 to what power equals 125. Okay, so there's two things going on. First of all, we're going from a fraction to a whole number, so we know that the exponent has to be negative. Okay, that's the first thing. Now, 5 to what power equals 125? Well, 5 squared is 25, 5 cubed is 125. So the exponent has to be negative, and it has to be to the power of 3. So it's -3. Gives us 125. So our answer here is -3. Okay. One last one like this that we'll go through. Okay, log base 36 of 6. So in this case, 36 to the power of x equals 6. Well, what happens? How do you get from 36 to 6? What would you have to do to get from 36 to 6? And again, we have to think of power, so certainly you can divide by 6, but that's not really the key thing. The key thing is the square root of 36 is equal to 6. So as an exponent, what exponent do we use for square root? Now that would be 1/2. So it's 36 to the power of 1/2 equals 6. So the answer here is 1/2. Okay, and the purpose of doing these problems is just to begin to get used to understanding or familiarizing ourselves with what logarithms are. You can use a calculator to solve these. Some calculators are set up better to do that. We will talk about that as time goes on. But for right now, that's really not what I'm looking for you guys to be able to do. You need to be able to take a problem like each of these and think through them mentally to get your answer. And that's kind of the goal for doing those types of problems.